Hello everybody, my name is Iman and this is my project Kept. So every product makes promises about itself, a landing page, a pricing table, a change log, a tooltip. Your code has many tests, but those sentences have nothing. This is Kept. It finds every promise your product makes, ties each one to a real browser test in Kane, and keeps a live record of which ones are still true. As you can see the graph over here, there are 8 promises and 7 of them are proven. One is red. Left to right, you get the document a claim is written in, the promise itself, and the test that would prove it, and then the evidence that Kane sealed when it ran. So every promise is cited to a file and a line. If the citation doesn't point at a real line, the promise never enters the graph at all. Now you can see the 8 promises and the most urgent one first. The red ones always come to the top. Let me click it. So this red one says the card gives 10% off above $50. That is a lie. There's no discount code in this app and there never was. So hold that thought, we'll come back to it. One thing before we go, today our example claims live in a README because it's the easiest thing to show you. But Kept doesn't know what a README is. It reads a path and a line number. So a promise can point at a heading in a React component, a row in a pricing constant, a line in an OpenAPI file. It's the same machine. Now, let me just go to this website. This is another website I created this is basically the app which is going to be under test. It's a coffee shop. Let me just increase the quantity there. So now, let's go to its README. As you can see on line 16 of its README, it promises that the card shows a running subtotal that updates when you change quantity. Right now, it does. So let me go to the cart. So this is the file. Let me just change this function. So I'm going to break it for real and save it. So I just broke it with one line. The subtotal now just reads the first item's price and ignores quantity entirely. This is a genuine regression, the kind that ships on a Friday. Now, I'm just going to go to the terminal. Just let me see the Kane CLI balance. Okay, so I'm basically going to run this command. I'm telling Kept one file change. It works out which promises that file can affect the blast radius and runs only those. Two tests here because both the subtotal test and the discount test touch the cart. And as you can see here, Kane's going to go now and do its process. It's going through a real Chrome, a real cart, and these are real clicks and it's not mock. I'm going to speed up this process. All right. So as you know, we ran the Kane CLI balance before. Then the Kane CLI actually ran. Was doing all of its cool stuff, and you can see I ran the credits command again, and you can see the credits have reduced. Now, yes, there'll be a new red, and you'll see that. Let me just go back to the website. Now, the title row changes from 7 proven, 1 red to 6 proven, and 2 red. Row 2 of the list is now red. The card screen, right? So the card screen shows a running subtotal, and row 1 is still that discount line. As you can see, I changed that code on the file in front of you, and it picked it up, and it showed it here, and it will show you the repair last verified by the designed test for it as well, and when it was cited. It will show you all. It will show you the screenshots. If I can just go to one of the screenshots. So this was the YML file. Let me just go to any one of the screenshots. It will show you the screenshots and it will show you the data completely. So there it is. Second red, and I never touched this page. Kept wrote a new snapshot. The ledger imports it. The dev server reloaded it, and row 2 is the promise I just broke. Now let me just go back to the terminal and run this command. And let me just make it a little bigger so it's easier to see. So now this is the part I care about. Kept read Kane's verdict and picked one of the 3 repairs. It will show you. Let me just go and find it. Yeah. So it says code break right here, right? So the product is at fault. So the agent may fix it. Now I also want to show you what it's allowed to edit. So now look at this. It's only allowed to touch the app source. It may not edit the README and it may not edit the test. Both of those would turn this green by lowering the bar instead of fixing the bug. That fence is in the code and not in the prompt. Now, if we scroll a little further down, you can see here that there is a warning. Basically, it's saying handoff code break unproven. And it's also naming the exact line in the README file, which is line 20. So now, if we go to line 20, as you can see here, the card screen applies a 10% discount automatically when the subtotal exceeds $50. So this was a chain that it caught, which was unrelated as it was in the card code itself. It caught this as well, but this was unproven. And here's the thing I did not expect when I built this. Let me just scroll up to it. Now, as you can see here, Kane looked at both the failures and called them both the same thing. Both were an application issue. And if you go up here as well, this is also an application issue. But the confidence was 0.95 for my real bug, which was the card screen shows a running subtotal that updates immediately when a quantity changes, as you can see here, the 16th one. And it gave me a confidence of 0.98 for the discount lie, right? The card screen applies a 10% discount automatically when the subtotal exceeds $50. This is just a straight apply. So they were both the same category, but the higher confidence one was the one that was fiction, right? It wasn't real. So Kept refused the second one, or over here, the first one. It says this promise was never proven, so there's no earlier state to restore, and patching it would mean implementing the claim instead of repairing the regression. So no path was authorized. Now let's undo the edit on line 106 and rerun the same verify command. So let me just put the line back in. Let me save it and let me just rerun this command again. And let me go back to the website. It'll auto refresh. Let's just give it a moment. Now, Kane is going to do its process of rerunning it, and I'll cut back to you once it's updated on the website. Now, as you can see, green. Kane sealed a fresh evidence break. So it basically did a break, detect, repair, and prove. So that's the complete loop closed. This was the one, and it is proven, and it's not read anymore. So it's not a promise that was not kept. The interesting one. It's the same read as before, but a completely different problem. This test asks for a 10% discount. The app has no discount, and it never did. So the test fails. But nothing is broken. The app is doing exactly the right thing. The sentence was just never true. Let me go back to the README and go back to the line 20. So there's the claim, line 20, and there's the test that checks it, which is the cart discount test.md, right? So here's why this is hard. Kane reads the test as the spec. So Kane can never conclude the spec is wrong. It can only tell me the app is broken or the test is like badly written. The sentence is a lie is not an option it has. So let me go back to this and let me go to the repair part, right? So now you can actually see what Kane actually reported. So right here. So the card showed $72 and kept it at 72 instead of reducing it to 64.80 cents. So this is completely accurate description, right, of a discount that does not exist. So if I just go a little bit above, and you can see right here, this is what Kane's verdict on it was. It was a test drift, as you can see here. It's a test drift. The test is badly written, and it gave it 78%, 0.78. But in the run I did just 2 minutes ago on the exact same failure, Kane said the opposite. The app is broken, right? It said about 0.98% confident. Same failure, same recording, but two different answers. That's not Kane being bad at its job. It's that the real answer isn't on its menu. So basically, kept asks a question Kane can't. And had this promise ever been proven? The subtotal had the repository watched it past with a sealed evidence. So when it went red, that's a regression, right? And repairing the code is the right move. The discount promise never has. There's no earlier working state to get back to. So patching code here wouldn't be a repair. It would be building a feature that nobody asked for because the sentence claimed it existed. So you cannot break what was never proven to work. So what does it do now? So it will take you to the third option, the one no test runner has. It proposes fixing the sentence itself. If we go to amendments, and we can see one of the amendments is pending. So out goes the 10% discount claim. In comes the cart, right? It shows the order total with no automatic discounts, which is what the app has always actually done, and it's writing nothing. This is a proposal for a human. That button doesn't even save. It hands you a CLI command when you run it. Kept rechecks the hash of that exact line and refuses it, even if one byte is moved. So you can accept it right here, and gives you the CLI command, and it will tell you exactly what to change. It gave you the proposed replacement, and it told you to go and change it in README, to change it from this to this, and gave you the reason, gave you the province, and gave you the artifacts if there are any. So this was basically the whole idea. Okay, now also let me show you it by running it. So I'll just copy the command and I'll go ahead and just run it here. And as you can see, the card screen shows the order total with no automatic discounts. So it did it by itself. So one line was written and the promise gets a new ID because rewarding a claim makes it a different claim. So the old one retires. Let me also just run this get difference. So as you can see, the one line, every other byte in that file is identical, including its line endings. It rehashed the exact line before writing and would have refused if anything had moved. There's also another one. I can show you another command, as you can see right there. So this will also be a CLI tool and an NPM package soon. Now continue with the rest of the demo. There's also the reviews page, the runs page, which shows you all the terminal events happening right here. It'll show you each and exact one. You can click on them as well, and it'll show you all the diagnostics which are happening as well. We also have a coverage page right here, which will show you the promises and the attestation first. And so bring it back here. The demo is already getting too long. I cannot show you every page, and I actually have a lot more that I wanted to build that's in the README on the roadmap. But that's basically the whole idea. 3 causes for a red promise. The code broke, the test drifted, or the claim was a lie. Each gets a different repair and a different amount of freedom, and only one of the 3 ever lets an agent write code by itself. So this page is completely deployed, but this is only read-only, and it spends nothing. So there's no keys, no server, no Kane, no file system. It reads from the counted file, right? And you can get your own run in 3 commands. Clone it, npm run demo to see the page with no count at all, or npm run loop if you have Kane credentials and want your own timestamp on it, or if you want to test your own feature on your own repo. There are around 2,400 tests written for this, 29 correctness properties, and every Kane fact in here was measured against the actual real CLI. So that's basically it. Your test, check your code, and kept checks what your product says about itself. Thank you so much for watching.